Hey guys, this is your study guide video to help you get through your study guide. So just fast forward to the question that you want help with and get the help you need. All right, so this is the first thing we'll look at is complex fractions. What we learned about these is that you want to multiply the top and the bottom by the little denominators. So that would be x and 3. So I'm going to start by doing the 3. That gives me 36 over x, and then 3x squared over 3, and the 3's cancel. Actually, I probably should just cancel them there and save myself the trouble. The next thing is I need to multiply the top and the bottom by this little denominator. Those go away, and now I've got 36 over x cubed. Most of you guys did okay with those ones. Let's go ahead and move on to the next one on the study guide. Same thing, just dealing with binomials instead. So we're going to multiply the top and the bottom by x minus 1. And good idea to cancel before you multiply. 1 times x minus 1 you would need to distribute, but that doesn't really matter here because it's just 1. 2 times 1 is 2. And 16 is going to be on the top now, and 1 is on the bottom, which means we don't really need to write that. From there, we're going to multiply the top and the bottom by the other little denominator, which is 2. 2's cancel, and I end up with x minus 1 over 32. Okay. Let's go ahead and take a look at another one. Once again, you guys didn't do too bad there. It's when we got into these ones you guys started having some difficulty. So in this case, we have 3 numbers involved. We have this number up here, and then we have this one here and this one here. And these 2 are fractions, and we need to unfractionize those. So what we're going to do is we're going to multiply the top and the bottom by each one of those little denominators. So I want to get rid of this little a, and I also want to get rid of the 25. So let's go ahead and start by multiplying by 25 here so that those cancel. But if I multiply there by 25, I also need to multiply here by 25. Okay? And I also need to multiply up here by 25. So what that ends up giving me is on the top 25a squared over 25 times 4 is 100 over a. Now notice I only did 25 times 4 and 1 times a. In class I saw some of you guys multiplying the 25 on the bottom also. You don't do that. It's straight across, okay? Minus, in this case we're just left with a over 1, which we're just going to go ahead and simplify that and write a. Now I want to get rid of the other little denominator there, the a, so I'm going to multiply this thing by a over 1. But if I multiply that by a over 1, I need to multiply this by a over 1, which is just a, and this by a. So in this case, these cancel, and now I have 25a squared over 100 minus a squared. And I do believe that would be the end of that problem. Oh, I goofed. A squared times a is a cubed. There's our answer right there. All right, let's go ahead and continue. Just another one. Just a little bit more complicated because instead of monomials, we've got binomials involved here. But this one has 3 fractions. I've got a fraction here, here, and here, all inside of one giant fraction, right? And I want to get rid of the x minus 3. I want to get rid of the 4. And I want to get rid of the 2. Let's start by getting rid of the x minus 3. So I'm going to multiply everything by x minus 3 first. So if I do that, those cancel. But if I multiply there by x minus 3, I need to multiply here by x minus 3. And I also need to multiply here by x minus 3. Okay? All right. So that leaves me with x times x minus 3 over 2. Now I could distribute in here, but I think I'm going to avoid that for right now. It wouldn't necessarily be wrong, but I think I'm just going to save that till last. Now here we have plus, then we have x minus 3 times x minus 3. Over 4. Okay? So there's that. Once again, I'm going to wait on this multiplication here. I'll get to that in a minute. Now I want to get rid of the other little denominators there. I want to get rid of the 2 and the 4. Usually, it's good to multiply by the bigger one, because sometimes when you do that, it'll cancel more. So I'm going to multiply that by 4 so these go away. But if I multiply that by 4, I've got to multiply this by 4, and I also need to multiply this by 4. Okay? Now, you'll notice in this case the 2 can divide evenly into the 4 to make 2, right? And so that also cancels out the 2. So now I'm left with a 2 and an x. I'm going to put the 2 in the front with the x, and then x minus 3. Here I've got 16. And then here I've got x plus 3 times x plus 3. I'm not plus 3, it's minus 3. Sorry about that. Now I don't see that answer, so that means they probably do want us to go ahead and do the distribution here. So I'm going to go ahead and distribute this, and I'm going to get 2x squared minus 6x over, and we also need to do that. Now before I do that, I'm going to look over here and see if I can find that answer anywhere. You guys see how this one is the only one that has that numerator? So I already know if I did everything right, that's my answer, and I can stop. But I'm going to go ahead and finish it anyway, just in case you want to see the whole thing. So x minus 3 times x minus 3, you would do a box method for that. If you want to see it, I will show you. If you don't want to, you can fast forward. That makes negative 6. So we have x squared minus 6x plus 9. Oh, it was one of our shortcuts anyway that we learned a while back. I should have just used the shortcut. And then we have 16 and 9, which makes 25. And there it is. Theirs are in a little bit of a different order than mine, but it doesn't matter. It's still got a positive x squared, a negative 6x, and a positive 25. So we're good to go. All right. Now we're moving on to solving. All right. So how did we learn how to solve? Well, first of all, we want to multiply everything by the denominators. So my denominator is 3r, so I'm going to multiply this by 3r, and I'm going to multiply this by 3r, and I'm going to multiply this by 3r. Now in the cases here, the 3r's cancel here and here, but here nothing cancels with this 3r, so you're actually going to go ahead and do 3r times 1. So let's see what we have as a result. 2r minus 2 stays just as it is without the 3r's anymore. 1 times 3r leaves me with 3r plus 3r's canceled here, leaving me with 4r plus 16. And now we're ready to go ahead and just solve it. So 3r and 4r make 7r. Let's do some basic algebra here. Okay, and there's my answer. Now, a lot of times when you're doing these problems, you could actually end up with an answer that's not allowed because it could make the bottom equal 0. But I think you guys know that if you were to plug this in here to 3 times that number, you wouldn't get 0. So it's a good answer. And it's something you really don't even need to worry about, honestly, in a multiple choice test unless you see one of the choices say no solution. If you see that, but you still get a number answer, check it to make sure that it's not really a no solution. Let's go ahead and move on to another one. Now this one is different from the last one because before we begin the process of multiplying to get rid of the denominators, what we want to do is we want to actually start by factoring the denominators. Now in this case, to factor this denominator, that's a GCF. They both have an x. So I'm going to divide an x out. If you divide an x out of those, you'll be left with x minus 1. This one is just x, so I'm going to leave that as x. Nothing you can do there. This one's the same one as the other one I did, so it's x times x minus 1. And now that we've done that, now we're going to multiply by the denominators, okay? So I'm going to multiply by x. Here the x's go away, here the x's go away, and here the x's go away. That leaves me with the following. But I still have another denominator I want to get rid of. I want to get rid of the x minus 1. So now I'm going to multiply here by x minus 1. I'm going to multiply here by x minus 1. I'm going to multiply here by x minus 1. In this first case, these go away, leaving me with 6. Here, I'm going to distribute the 1 to multiply those together. Notice we're actually going to do some multiplication here because this x minus 1 did not get canceled. So we're going to go ahead and distribute it in to get x minus 1. And then over here, these get canceled as well. So you're left with 1. From there, we're ready for some basic algebra. 6 take away 1 is 5. Minus the 5 on both sides, and you've got your answer of -4. Once again, you want to make sure it doesn't make the bottom equal 0, but on this problem, it doesn't really matter because no solution is not even an option. So our answer must be the correct one. All right, let's go ahead and move along to another problem. Notice on this one, some of the choices have 2 answers. That's a good indicator. You're probably going to end up using factoring or the quadratic formula to solve. I'm going to say factoring because that's what I'm going to do. But let's go ahead and begin. So first of all, it's like the last problem in that the first thing you want to do is you want to factor the denominators. So down here I can take out an n. Now I want to multiply by the denominator, so we'll start with the n. N's go away. And that leaves me with, I'm going to put that in parentheses. It's a good idea to put your parentheses in parentheses around your binomials. Okay, we're going to repeat the process now to get rid of the n minus 5. So I'm going to multiply all these by n minus 5 now. Okay, so here they go away, and here they go away. But here they do not go away, because the n minus 5 doesn't have anything to cancel with. Here is another box multiplication problem. This time I'm not going to show my work for the box, but you would get n squared minus 11x plus 30 if you boxed this out. Okay? Here we're left with nothing but a 1, and over here we're left with nothing but a 3. Now, oh, I put x. Shame on Mr. Bailey. That's supposed to be an n, so it's 11n, not x. Okay, so now what we have here, you guys, is we've got a quadratic equation. You have a squared and a regular n. I'm going to put these together here. When you have a quadratic equation, what you want to do is you want to get it to equal 0. So we're going to minus 3 on both sides like that. And what that's going to end up giving me is n squared minus 11n, and I believe minus 28. Now you could solve this using the quadratic formula, but I'm going to use factoring. Any of the problems you guys end up having should be factorable. So I will review how to factor with you for this one problem here. So the first term goes in the top left, last term goes in the bottom right. We look for 2 things that multiply to make n squared, and that would be n times n. And we look for 2 things that multiply together to make, I think I had a little boo-boo. This was positive 28, you guys. Sorry about that. Anyway, now we want to look for 2 things that multiply together and make 28, and that would be 4 and 7. And then we know we've factored it correctly if these 2 terms can give us negative 11. And they can if they're both negative, which means these both need to be negative. And therefore, the polynomial factors into n minus 4 times n minus 7 equals 0. Then we set them both equal to 0. And we solve. There's one answer. Okay, now we have to be careful here. You do want to make sure that neither one of these make the denominator equal 0. Now in our last problem I told you if it doesn't say no solution, you don't really need to worry about it. But on this one that's not true, because it's possible that one of them works but the other one doesn't. In which case, even though one of them may not be a solution, the other one will be, and they may not have the words no solution here. So we actually should take the time to check it. Right now the answer looks like it's this. Okay, so if you were to plug in 4, that would be okay here. If we were to plug in 4 here, you would get 4 squared minus 4 times 5. That would be 16 minus 20. So that's not 0. So we're good with 4. So we know we can keep 4. Let's check 7 though. 7's good here. Let's see if it works here. This would be 49 minus 35. That's not 0. So we're good. So both answers work, and the answer is 7 and 4. All right, continuing. Another one of these things. I think I'm going to leave you guys to do this one. I will tell you the answer though, so you could check to see if you're getting it right and why or why not. You should end up getting D. Okay. So here's our next problem. I'm going to need to get out of this view to find out what our question is though. Just a second. So for number 9, let me zoom in here a little bit. Okay, so for numbers 9 through 12, we're using the equation at the top there. Trying to get a nice view for us so we can work here. Okay. Let me create some writing space and we'll get started. Okay. So we talked about how to graph functions that look like this. Okay. We talked about how h gives us the vertical asymptote. But notice it's going to be the opposite sign. So whatever number's here, h will be the opposite because there's a minus in front of it. And then k will be the horizontal asymptote. I guess I'll say x equals h and y equals k. Semicolon there instead. Is the horizontal asymptote. So that's one thing we talked about. We also talked about how this sign and this power work together to tell us the shape. Okay, so if n is an even power, then it either goes up when a is positive, or it goes down when a is negative. And your asymptotes are here. Okay, if n is odd, then it goes like this. If a is positive, and if a is negative, it does the opposite. It looks like this. So let's go ahead and take a look at exercises 9 through 12. So what's the horizontal asymptote? Well, I told you guys k is the horizontal asymptote. On this particular problem, there is no k, so we can assume that's 0. So my horizontal asymptote would be y equals 0. What's the vertical asymptote? This letter here tells me what the asymptote is. That would be this one here. So And remember, it's always going to be the opposite. So my vertical asymptote is going to be x equals 2. So I'm going to go ahead and graph this now. We start by graphing the horizontal asymptote. It's at 0. And then we graph the vertical asymptote, which is at 2. And then we use the power, which in this case is 1, and the fact that this is a negative in front. Okay, so I've got a negative a and an odd power. So my graph is going to look like this. I don't like how I drew that second one. Let me fix that. It's not supposed to cross the asymptotes. Should get really close to the asymptotes, but it shouldn't cross them. Okay, the next question says complete the statement. The limit of y, which means the limit of this function as x approaches infinity, is what? So, just reviewing our function notation, this tells you which way we're going. It says x is going to infinity. This is the x-axis, right? And if I'm going to infinity, that's positive infinity, that means I'm going this way. So we're traveling along our graph and we're going that way. And as I go that way, the question here is what's my y value approaching? Well, notice it's getting blocked by the asymptote, but it is getting closer and closer to that asymptote. So as we go off into infinity, the y value is getting closer and closer to the horizontal asymptote, which is 0. Okay? For number 13 through 14, I'll let you guys do it. I will tell you the answers, but ultimately, I would encourage you guys to come pause the video here, work on your own, and then just check out the answer. I'm not going to talk much. I'm just going to put the answers up. So go ahead and pause the video here, and you guys can see it in just a sec. And there you guys go. Good luck with your quiz. We'll see you guys later.